Muhammad Umar Farooq biological video. Please make sure to subscribe, like and share. Ask the question for answer and comment about the artwork. You can also answer question to each other for solving the problem in the comment below. So today we will discuss about the explain about water potential with reference to osmotic and pressure potential. So what is the water potential and what is the osmotic potential and solute potential we will discuss, and what is the transport. In this video we will discuss whole this concept about the potential. So first of all, let's begin to understand the translocation. So the trans mean the change, location mean the place. The translocation is the movement of substances through the conducting or vascular tissue of plant is called translocation. It means the movement of substance from one place to another place is known as the translocation. So here I am drawing the vascular system which that are present in stem, root and their leaf. So the xylem and phloem is the important conducting tissue which they are used for the food and water conduction. So here is the xylem. Xylem translocate which that are present in the inside, and translocation of water mineral salt which that through xylem, while the phloem is the translocation of organic and inorganic solutes mainly from leaves to other organ like fruit, roots and stem. So the transport is the another concept about that movement of any object from the one place to another place is known as the transport. So let's begin to understand the transport. So the transport means the transportation of the transport is basically the movement of any object movement from one place to another place is known as transport. So that is same translocation and transport, but translocation is occur in the xylem and phloem, while the translocation and transportation is the basically are present within the cell via a plasmodesmata. For example, here the water constriction is more in one cell, so that means the water move toward the lower constriction of the water. So that is plasmodesmata is the major source for the movement of water within the cell. Cell to cell connection is bound with the plasmodesmata. So that is plasmodesmata is the junction like structure which that is we are not understanding in this video, but later on we will discuss in next video. So on the other hand, transport is in two type. Translocation is just simple, we can explain, but transport is due to the higher constriction to the lower constriction via ATP use. So that is against the osmotic gradients. That means the low constriction to the high constriction move by the activation of the energy by the using of the energy via ion change. So the higher potential to the lower potential, that means it means the low constriction to the higher constriction movement is required energy, while the passive transport means the higher constriction to the lower constriction. For example, the potassium move inside while the sodium move outside is against the osmotic gradients. So on the other hand, osmosis is the movement of molecule from one place to another via a semi-permeable membrane. So let's begin to understand solute potential. What is the solute potential and what is solute? Solute is basically less amount in the solution, while the higher amount in the solution is known as the water sol. For example, water is the solvent and solute. So that's solution. So the lowering of constriction of water molecules by effect of dissolving of solute molecules in pure water is called solute potential. So what is water potential? First of all, the solute potential is the meaning of that the lowering of constriction of water molecule by effect of dissolving of solute molecule in pure water is called solute potential. So the pure water will dissolve the solute, it become a solute potential, and solute potential is every time is negative because it's absorb water but it's not excrete water. So here is the water potential. The tendency of water molecules from one place to another is known as water potential. So that means water have potential or some potential which that is able to move from a higher molecule to the lower because it contains a kinetic energy. So that's kinetic energy is used for it. So here is the beaker which contain a semi-permeable membrane, and one side is the water potential is negative due to the higher amount of the solute, for example salt and minerals. On the other hand, the water potential is positive. Water potential is zero when the molecule will be zero mean the positive when the molecule is same molecule of water. So that means the water potential higher positive to move the negative. It means we are a permeable semi-permeable membrane. So what that means? That means the water potential if zero, it means the maximum water potential, and that means the zero to move the negative water potential to ultimately balance the balance the water potential in both sides. So that is important. Water always want to maintain their water potential within the within the two cells adjacent cell or two adjacent beaker is put the semi-permeable membrane. So on the other hand, pressure potential. What is pressure potential or turgor pressure? So the pressure tending to force the water from one place to another is called pressure potential. For example, the pressure tending to force the water from one place to another is called pressure potential. So what that means? Here is the shrinking of the cell which contain a less amount of water as compared to the environment, so the water will move. It means the potential is the maximum, which that means cell is able to absorb more water because mineral is more. It means the water potential inside is a negative while outside is a positive. So that means water will move inside, and here is the vacuole, and salt more inside. So that means water will be not excrete easily again back into the environment due to the cell wall, and osmosis will be occur. Ultimately the turgor pressure generate. So that is mean the pressure built inside, and salt plus water which that is build the pressure inside push the wall of the cell to create the pressure potential. So the pure water is directly proportional to the pressure potential. It means the pure water is more, so it means the pressure potential will be more if the environment contain pure water. So that means that it is directly proportional to the pressure potential. So pressure potential means within the cell which that is give the pressure. So it means the increase of the water to increase the pressure potential inside of the cell. So on the other hand, example of solution is that water, for example solvent, and sugar, for example a solute is the sugar and solvent which contain a solution. So that means the higher amount of molecule is known as the solvent in the solution, while the sugar is the less amount of molecule is known as the solute. On the other hand, keep in mind, greater water molecules is directly proportional to the water potential, and water potential is directly proportional to the kinetic energy. It means the more water potential, so the more water kinetic energy in the pure water, and greater water molecules in the pure water, and increase of solutes mean decrease of water potential. So that is opposite the solute potential, always negative. So let's begin to understand the water potential with reference to osmotic and pressure potential. So the water potential, what is that? Semi-permeable membrane is, again I am drawing that beaker, and pure water is one side while the other is contain a solution. Solution means it's contain a salt or some minerals, and that means the higher water potential means the zero, and the lower water potential means the negative is here. And that means the movement of water from higher concentration of the water to move the lower concentration of the water to maintain and balance the water potential in both sides. So it means the water potential is equal to 0 means higher number of molecules, and it means the maximum potential when that molecule pure water to move into the solution. So that means the water potential will be lost in the pure water. So that means the water become a negative ultimately after the movement of molecule. So that is here is a moves from the pure water to move the solution, which that is the basically another ways you can understand. So that means here is the osmotic potential. What is the osmotic potential? Osmotic potential mean the cell is able to osmosis inside and osmosis. So the trigger potential basically if pressure greater than atmospheric pressure is applied to pure water a solution, its water potential is water potential increase. So how that is possible? So let's begin to understand. Here is the atmospheric pressure, which that is basically higher inside of the cell, for example. So it means water will move inside. So that means inside the water potential is increased as compared to the atmospheric pressure. So that means the pressure potential is more inside. So the osmosis will be occur and this solution will be formed. And inside vacuolar pressure or trigger pressure is more, and that means the water will move outside and want to move outside. So that is the best example is the transpiration in the plant or evaporation of the plant water. So let's begin to understand. Here the atmospheric pressure ultimately going to maintain outside due to the water move outside from the cell. So that means important thing is that the water is released from the cell after the puncturing of the cell. So that means the water evaporate due to the water potential, just like a leaf which contain a mesophyll cell, and decrease the water potential, decrease the atmospheric increase the atmospheric pressure by the transpiration or evaporation. So that means the water potential is always equal to the sum of the solute potential and pressure potential. So that means it is known as that. So let's begin to examine the following diagram cell to understand what is the water potential, and I am asking the question about that, and you can understand easily. And you can, if you have any concept about that, then you can solve this problem easily. So here I am drawing the two adjacent cell. Freely permeable cell wall are present, for example, and cell A and cell B. So between the cell A and cell B, the partially permeable cell's surface membrane. So what does that mean? Here the water potential is negative 1200 kilopascal, while on the other hand, and the second cell contain a negative 800 kilopascal, while the pressure potential is equal to 800 kilopascal, while the pressure potential on the other is 600. So here is the kilopascal mean the 1000 pascal, which is the pressure exerted by a vertical force of 1 Newton on an area of 1 meter square. So that is equal to the pascal. So that's kilopascal is made up of 1000 pascals. So here is the solute potential is the 2000 in the A cell, and the solute potential is negative 1400 kilopascal. So what that means? The partially permeable membrane cell surface. So let's begin to understand, and I am giving the question to solve by yourself, and at last I will give the answer and give the concept about that. So which cell has the higher water potential? What that means? And in which direction will water move by osmosis? And what will be the water potential of the cell at equilibrium? So what will be the solvents? What will be the solute potential and pressure potential of the cell at equilibrium? Equilibrium. So that means when normal the cell water potential, so that means it will be equilibrium. So that means equilibrium, what will be happen? Let's begin to understand. So the cell A contain a negative 1200 kilopascal water potential. It means higher than the water potential in B because it is negative, less negative. Less negative means the more water potential. So that means water will move from cell B to cell A. On the other hand, the water potential is equal to 800 kilopascal pressure potential of the cell A, while the pressure potential is the 600 kilopascal on the cell B. So that means the pressure potential is more greater in the cell A. So that means the pressure maintenance, how it will be equilibrium. So we can adjust it and we can give the equilibrium. So here I am giving the equation is the equilibrium is equal to the cell A plus cell B over 2. That is the ratio to understand. And when the equilibrium is state is the E is equal to 1000. It means when the both cell contain a 1000 water potential, so that means the equilibrium state will be occur. On the same phase, the pressure potential is equilibrium state is the 700 kilopascal, while on the other hand the solute potential is also will be equal when the water move from the from the less negative, that's more negative. So the more negative contain a more solute. So that's all thing is done here. Let's subscribe this channel and bye.